Alright, let's look at the homework 5.1, 5.2, problem number 9. Alright, so it says that use s double prime of t equals negative 32 feet per square second as the acceleration due to gravity. With what initial velocity must an object be thrown upward from the ground to reach the height of a national monument, which is 550 feet? Round your answer to 2 decimal places. Alright, so let's do that. Alright, so let's say you start from the ground and thrown upward with the initial velocity, say v0. Alright, so what happens is this is going to go up, and due to gravity it's going to slow down, and eventually it stops and start to come down. Right? So you can see that at the very top, velocity here, we know that the velocity here is 0. Right? And that will be the highest point. Alright, so using that information, let's try to come up with the equation to find the initial velocity. Alright, so since we already know the acceleration, so s double prime of t is equal to negative 32, right? Then we can find s prime of t by simply taking the antiderivative of negative 32 with respect to t. Right? And this is going to give you negative 32 t plus some constant. I'm going to call it, say, c1. And remember that the first derivative is the velocity function. Alright, and initial velocity is v0. So let's plug in t equals 0. So it's going to be 0 here plus c1. Alright, so c1 is same thing as actually v0. Alright, so which means that we found the v0, v of t, right, is equal to negative 32 t plus v0. Alright, so once you know the velocity function, we would know when the object reaches the highest point. Right? So that's when the velocity becomes 0. Alright, so we can just set that equal to 0. Alright, so if you solve for that, for t, let's see, we can just add or subtract v0 from both sides. Then you have negative 32t is equal to negative v0. Then we can simply divide through by negative 32. Alright, so t is equal to, alright, negative sign cancel out, so you're just going to get the v0 over 32. Alright, so this is the time when the object reaches the highest point. Alright, then we have to talk about the highest height too. So we have to come up with the s of t function. So we have to take another antiderivative. So if you want to find the s of t, right, then we can just take the antiderivative of the velocity function which we just found, which is negative 32t plus v of 0 with respect to time. Alright, so this is going to be, alright, negative 32 is just a number. Alright, and add 1 to the power and divide by that power. And v0 is a constant, so antiderivative of v0 times t. Alright, then you have another constant to say c2. All right, but since the object is started from the ground, assuming that the height will be 0 in the beginning, so s of t is actually 0. So s of 0 is 0, right? But if you put 0 here, 0 here, you c2, and this is going to be 0. So c2 is actually 0. Alright, so let's clean up a bit. So 2 and the 32 cancel out, so that's 16 there. So what we get is this. Alright, so therefore we have s of t is equal to negative 16 t squared plus v of v0t, and this is just going to be 0. Alright, now we have used information here, so we used the second derivative, right? And then we haven't used this information here. So the highest point is 550 feet. So at the highest point, which happens when t equals v0 over 32, the height function is going to have a value of 550, right? So let's do that. So s of, right, remember that the highest point occurs at v0 over 32, so we plug that in here. So we get, let's see, s of v0 over 32, right? So this is going to be equal to, right, negative 16 and t squared, so that's going to be v0, so we plug in v0 squared over 32 squared, right, and plus, and v0 times v0 over 32. Alright, so what's this? Alright, so let's see, 32 and 16 cancel out, so you have cancel this and cancel one of the 32, but there's still 2 left over. Alright, so this is going to be negative v0 squared over 2 times 32 is 64 plus v0 squared over 32, right? So this is simply v0 squared over 64. Alright, and we know that this guy has to be equal to 550, so we set that equal to 550 because that's the highest highest point. Alright, then we can solve this equation for v0. Alright, so first thing I would do is multiply both sides by 64. Alright, and then we get the v0 squared is equal to 550 times 64. So I'm lazy, so I'm going to just leave it as that. Then take the square root. So we get the v0 is equal to, and we don't have to do a plus or minus because we're talking about the initial velocity, which we assume to be positive because you're shooting upward. Alright, so you have 550 times 64. Actually, square root of 64 is 8, so can I probably put 8 there? And actually, I wrote something wrong here. So this is 550. Alright, so 550. Alright, so let's find that value here using a GeoGebra. Alright, so I opened up a GeoGebra and we want, let's see, 8 times square root of 550. Alright, so let's get that value. Alright, so you have 187.62, right? So 187.62, feet per second. Alright, so let's type this guy in. Alright, so what we found was sorry. Alright, so what we found was 187.62. Alright, so let's go down and submit for testing. Alright, it came back and it looks like we got this one correctly. Alright, and that's it. I hope that this was clear.